One fiber is involved, the only neurotransmitter used is acetylcholine. It's always excitatory. In the skeletal muscle, it will always get a response. Okay? Now, if something happens to those nerves, then the muscles wouldn't work. So now, the autonomic division, viscera. We're looking at glands of the body, smooth muscle. It innervates cardiac, but does not control it. For the most part, it's all involuntary. We're not controlling these actions. The nerve endings are called veracosities because they're leading, for the most part, to the viscera. And they kind of use it as a graphic representation of like just a huge lump on that organ or the gland. Okay, so they call that nerve ending a veracosity. Okay, and it's internal. We have two fibers involved now, pre and a post. We have more neurotransmitters. Acetylcholine, yes. Norepinephrine, yes. Now here's the difference. They can function to be excitatory, meaning let's bump up that heart rate. Let's bump up that breathing rate. Let's bump up that blood pressure. Or it can inhibit. It can stop those processes from occurring. We're going to say that they either create an excitatory potential or an inhibitory potential. It's really cool how all that works. And if something happens to these nerves, they can actually get more sensitive and create some really bad effects in the body. They can become hypersensitive and cause stuff to either overreact or underreact, both of which can be deadly to the organism, i.e. the human. It's really kind of cool. Think about it.
What's an example of that?
Okay, let's say that maybe there was a car wreck or some type of work injury or something like that. And it can, even though we tend to think of those types of injuries on the large scale and how it might have hurt the spinal cord or those large nerves that might be exiting, and because we associate, for the most part, that to what happens to an area of the body, like say for example, they might lose some ability in their arm or lose some ability in their legs, and if it's completely severed, if the spinal cord area is completely severed, it's paralysis, okay? But to the organs served by that spot of the spinal cord, it can cause them to be overactive or underactive. Because don't forget, now I think we all have that understanding of this great big huge spinal cord and the nerves that exit, leading to our skeletal muscle. Now, when I came around and I kind of showed this chain and the little branches that happen, those branches go to a specific spinal nerve. So if something happens at this region, it would stand to reason that anything this chain ganglia right here serves would affect those viscera. Yes, no, maybe? Yeah, think about that. That's kind of cool. You know, I mean, have y'all ever thought about that before? Ever thought about why somebody who might be paralytic, like whether, you know, it's the lower limbs or whether maybe it's the upper limbs and everything, they have no control, for example, over their bowels or their bladder. They don't have that control. It's been severed. Yeah. Story thickens a little now. So this is why it's good to understand, because you know, chances are once you're out into the field that you've chosen, you're going to come across a patient who has had spinal injury, and along with that, the organs that are served.
It might be a little different, but I actually had to do a project on fibromyalgia my last semester,
Okay.
and even though like the pathophysiology of it is, they're still like researching. There's no definite cause of fibromyalgia. They actually look at how the nervous system plays into that, and how you mentioned how traumatic experiences such as like those of physical or mental, you know, that it can cause an overdrive of the HPA axis system, which also involves like cortisol or adrenaline. How for some reason it doesn't stop, so it goes into overload, which means they can't produce it anymore. So the person, therefore, you know, they're experiencing their different parts of their body are like experiencing stress, and it's like painful. Like they, you know, people with fibromyalgia, like if you touch them, it hurts. Yeah.
Yeah.
So
It's an oversensitivity of those nerves.
Yeah.
Underneath the skin areas.
Yeah.
And I'm like, I don't know if they've really, you know, identified the true reason.
No.
So I know that they have created the medications that go in and try to calm those nerves down.
Right.
And some of them I think have been more helpful than others, which is definitely the better treatment than it used to be 20, 30 years ago, which was just straight up, you know, like prednisone or something. Oh, man. But yeah, it's very painful for them, and their nerves are just oversensitive. Yeah. And this, nerves as a whole, okay, are pretty mind-boggling, okay? People who truly understand this neurobiology, I mean, I would love to talk to them, because I don't have a full understanding of it. It's just so complicated for me. But our nervous system, whether we're talking our peripheral or whether we're talking autonomic, the things it can do to the body is pretty amazing, especially when we're talking getting into these organs and so forth. So as we look at these divisions that exist, the sympathetic and the parasympathetic, even though we have our chain that exists, the two divisions are going to be served by different regions. What are the regions of my spinal cord area? Okay, so I'm sorry. Okay, cervical,
thoracic,
lumbar, sacral, and our little coccygeal. So, my sympathetic division, we call this thoracolumbar. What two divisions does that make you think about? Thoracic, lumbar. Okay? Because this division is coming from these regions. Now, here's one of the differences I mentioned. The pre and the post fibers, one will be long, one will be short, one will be short, one will be long. Okay? In my sympathetic, pre are short, post are long. The pre nerve cell bodies, all right, neurosomas, nerve cell bodies. Do you guys remember in the spinal cord when we looked at the section and it looks like the butterfly, all right, and to that butterfly, I pointed out the ones to the side, okay, those are the ones that deal with my autonomic nervous system. I think they're in this picture right here. Yes. Remember how we had the horns and everything? And then I pointed out the little point to the side, okay, the lateral. This is my lateral horn. So, for my sympathetic division, that lateral horn is where neurosomas are going to be for the pre-fiber. And then fibers will exit by way of the spinal nerves from T1, which is my thoracic region, to L2, which is the lumbar. So, if I'm looking at this, and I look at T1, and I go to L2, the fibers, the spinal nerves that are exiting, this allows for those fibers to be with my sympathetic division. Okay? So, they're going to go to the chain, those chain ganglia that I pointed out. And, well, I've already pointed out they're to the sides, okay? And these are how many of the bumps, the ganglia that tend to exist, okay? So 3 in my cervical region, 11 in thoracic, 4, you guys, okay, follow that, all right? So from those ganglia, post fibers, okay, get to go to other levels of the body. Okay, so this is what it looks like in a cadaver. So in my thoracic and lumbar area, this is actually the chain that's running outside, okay, and then these fibers get to move with a spinal nerve. So, in a graphic representation, thoracic, lumbar, they'll give rise to the pre-fiber that makes its way to the chain, and then the post-fiber makes its way to the organs of the body. Does everybody kind of follow me there? Mm-hmm. Now, look back at the picture. In this picture, for my pre-fiber, which is being represented in green, okay, does every single one of the greens synapse in a chain?